I guess let's go ahead and get started. And welcome to all of our viewers who are watching us via live broadcast. This is our Human System Integration Knowledge Broadcast Series, and we have a couple of presenters today. I'm just going to give a brief overview to get us started and then pass it off to our presenters. There you go. So just to go over it a little bit again, what are these knowledge broadcasts and what are they all about? The Knowledge Broadcast Series is an in-reach effort to increase awareness of really what we're already doing today, mostly at the directorate level or within the directorate on many different levels, in regard to human system integration, looking at tools, practices, general areas of interest. We do have a SharePoint site, and that's shown below under this HSI Knowledge Broadcast website. And so all of these presentations will be in presentation format on the website, and the presentations themselves, as they're being broadcast, are also being recorded, and those recorded presentations will be logged on the website as well. So just kind of overall, again, to set the stage for what you're going to hear about today, human system integration does just that. It integrates human health and performance concerns. So it allows for the crew to be considered as part of the system and part of the total system performance. So that helps to identify key drivers to vehicle design or architecture, to help shape operational concepts, and also to evaluate crew needs. And one of the important things is that allows for humans to be traded or to be considered in trades equally with other vehicle subsystems. And the importance about this is that, again, we do bits and pieces of this now, we really do, but it's important to do this not as an afterthought, but to do it throughout the project life cycle. And that's all the way from the very beginning to the decommission, through operations into the decommission. And so in Doug Wong's pitch, you're going to hear more about kind of the organization and how the people have been set up to do this. And in David Fitt's pitch, you're going to hear more about this tie to the life cycle. So we really do a lot of this, but again, we're just trying to connect the dots. And you're going to hear David talk more in David's pitch than in Doug's pitch, but you're going to hear him talk about these domain areas, and that's kind of what these puzzle pieces are representing. We're still figuring out what definition is tied to each one of those little puzzle pieces, so to speak. But that's not the important part here. The important part here is we're all working towards one end or common goal, and reducing life cycle costs, making the mission safe, making sure the crew is safe, improving system performance, and we do that by considering the crew as part of the system. So again, HSI, just an overview, helps us to connect the dots and to look at that bigger picture in regard to human systems integration, where we're looking at human health and performance. So with that, I'll go ahead and hand the presentation over to our first presenter, who is David Fitts. This presentation that he's about to present was developed for the HSIS conference, which is going to be in a couple of weeks. And David is our branch chief for the Habitability and Human Factors branch here at Johnson Space Center. And with that, I'd like to pass it over to David. And let me give you the mic, and I'll go ahead and get your presentation queued up.
Great. Thanks, Debbie. And the first thing I'd like to do is thank Debbie and Rhonda and Kate for setting up this series. I'm really pleased to see this attempt at broadcasting more information about human systems integration and bringing more awareness to the table. I'm feeling just a little schizophrenic about today's presentation because this presentation was developed for Human Systems Integration Symposium, a conference that occurs every year in Annapolis, Maryland, and it's primarily a Department of Defense conference, symposium, and primarily bringing human systems integration practitioners together. So I'll be singing to the choir, if you will, about human systems integration. This will be a very informed crowd, but I also feel a need today to help explain a little bit more to the audience watching this broadcast what human systems integration is and what it might mean to NASA. So with that in mind, I added a couple charts here at the beginning. The first one gives a definition for human systems integration. This is from INCOSE, the International Congress for Systems Engineering, who are very interested in looking at HSI and integrating it into the systems engineering process. And the definition is that the HSI is the interdisciplinary technical and management processes for integrating human considerations within and across all system elements. What's a human consideration? It's any discipline that relates to human concerns, and that includes a wide variety of disciplines, everything from psychiatry to medicine to human factors engineering to environmental engineering, anything that takes the human into consideration more perhaps than strictly systems engineering might. In the Department of Defense, human systems integration, or HSI, has a very specific meaning. That's because HSI was mandated a few years ago as a requirement for all acquisition contracts. I'll touch on that a little more. But a little more on what HSI might be. HSI focuses on human and system performance. There are some disciplines, some human considerations that might focus more on the performance of the human, and others that might focus more on performance of the system. For example, in medicine and behavioral domains might focus more on how we can help the human perform, whereas human factors engineering, habitability, environmental factors might focus more on how we can help the system accommodate the human. But overall, the discipline of human systems integration is looking at the interaction of the two. How can we measure and increase the performance of the human plus the system? So since about 2000, HSI is mandated in the Department of Defense. And right out of the mandating words, it says the project manager shall apply HSI to optimize total system performance, operational effectiveness, and suitability, survivability, safety, and affordability. And let me make it clear up front, and it will be very clear to this symposium, the purpose of this mandate for HSI was not to make nicer user interfaces. It was to save money, because what the Department of Defense was finding is that 80% of the operational cost of any weapon system occurs after the project manager who's developing the system says, I'm done. It occurs in the operations field, everything from the user interactions to the maintenance of the system, the deployment of the system. So all of those costs together are much more expensive than the actual development. So the military is looking at how you can learn from those operational needs and bring that back into the development cycle and make sure the human is always considered in the development of the system. HSI also is well defined in terms of which domains. Now this varies from service to service, and this is primarily the Air Force's model, but the disciplines include human factors engineering, habitability, environmental factors, occupational health, countermeasures, survivability, system safety, training, manpower, and personnel capabilities. And I've highlighted the ones that I feel there's a counterpart to in the Space Life Sciences Directorate here at JSC. We are looking inside Space Life Sciences at what we can learn from this DoD model of human systems integration to better integrate across these human concerns, particularly, of course, the ones that are highlighted. So I'll start with the charts that will be for the presentation. I want to emphasize to this group, we've been talking for a number of years, and they're very interested in what NASA is doing because in some ways what we're doing is working more effectively than what's happening in the DoD. In other ways, we have things to learn from them. Even though there was a mandate that says you shall include HSI, they're still trying to, they're still dealing with basics on how you actually make that happen. So I want to emphasize to this group that there is no HSI agency-wide perspective or mandate in NASA. What we've done to perform equivalent functions has been on our own based on what we see as the need for integrating human concerns into the system. At the Johnson Space Center, where most of the human spaceflight programs reside, and most of the projects that relate to human-carrying vehicles, such as the orbiter, such as CEV, such as the lander, the primary provider of the equivalent of HSI capabilities is Space Life Sciences Directorate here at JSC, although we definitely include disciplines and activities from other directorates as well as capabilities from other centers. This is the NASA project lifecycle. This is a snapshot taken right out of the NASA Systems Engineering Handbook. And the purpose of including this is to illustrate to our counterparts in the DoD that our roadmap for a project lifecycle is not that different than the DoD roadmaps. It includes a period of project formulation, a period of development in which products are ultimately delivered, and then a period of operations. A model that I have used in our own branch, Habitability and Human Factors, for a number of years is this model. And I've said in order for us to have a capability, a fully functional capability in human factors and habitability, we have to be active in and capable to perform in these 6 capabilities. Requirements development. We have to be able to write good requirements that are measurable, objective, and verifiable. We have to be able to supply requirements integration teams that work inside programs and projects that help explain to people the nature of our requirements, why it's important for them to flow to every element of the project, and in some cases, what it is we're looking for as an outcome. I certainly have found that most project managers come from an engineering background, and having had much of an engineering education myself, the engineering curriculum doesn't often deal with human interfaces. And so people practicing in engineering aren't always equipped to deal with the human. We're here to help make that happen. Design, when requirements aren't enough, we roll up our sleeves and get involved in the design activities of a project. Verification, that's confirmation, formal and otherwise, that our requirements are being addressed and being met. Operations, where we look at the post-deployment period, where we look at operations and say, well, how well did all of that preliminary work during development work? And then research, where we have the opportunity in a functional human factors program to go back and fill a gap where we learned that hey, we needed better requirements in a particular area, or we needed to address a capability or concern that wasn't addressed well before. So when all of these things are addressed well in a project, and this applies to, I feel, any domain within human systems integration. I use this model for human factors and habitability because I know we use it in the branch, but I feel this would apply to any domain. When all these capabilities are effectively addressed in a project through the life cycle, using the term vertical integration occurs. In other words, that particular domain or function is vertically integrated into the program or project. Horizontal integration occurs when you put the integration into HSI. When you look across the human domains or human-centered design domains, and you come up with a cohesive, common answer that the programs are looking for, in the same way that systems engineering and integration works among hardware and software engineering. How do you come up with a consolidated human systems integration input to a program or project? We're calling that horizontal integration. And the intent here is to deliver a cohesive product, not for each of these domains to go forward to a program and project with their own interpretation, but how can HSI or some equivalent to it in NASA deliver a cohesive product of programs and projects. And what I'm proposing in this presentation is an approach to doing this, because on the previous chart, the DoD, we find, is continually asking the question, well, how do we do this? We have this mandate to do this, but how do we perform this horizontal integration? And in our experience, and certainly in my experience in our branch, one way to do this is to take those 6 capabilities and break the horizontal integration process into 6 horizontal integration processes, each having its own series of practices and techniques that make it work, and thereby each becomes a more manageable process. And in effect, this ends my presentation. This is the message I want to get across. I could say go read the paper if you want to get more information, but I have 14 more charts. This is the message I want to get across at the symposium, and I think it will be of interest to people because they've been dealing with this issue of how you perform this horizontal integration. One person we talked with recently at the Army Research Laboratory said, in effect, they don't know how to do this. They don't know how to take information from these quite varied domains and integrate them into a cohesive response. So they basically take the reports from each one and staple them together. We're looking at a more proactive approach. I'm going to talk about each of these 6 capabilities briefly here. Requirements development. Requirements is where we take our standards, and in our particular branch, human factors, I thank our forefathers for, in the 80s, having the foresight to develop the Manned Systems Integration Standard, or NASA Standard 3000. Yes, thank you, Barry. Because I feel this gave human factors a future in the International Space Station program and in the Constellation program and programs yet to come. Because when people were already familiar with this document, when International Space Station or its predecessor Freedom were in formation, they said, well, we want this integrated into our program. And again, I'm grateful that it existed. So what happens when a project or program is in formation is we take these standards and we develop them into program-specific requirements. This happened on Space Station, and from NASA Standard 3000 we tailored or derived SSP 50005, the Space Station specific equivalent, and for Constellation Program, the Constellation Program 70024 or the Constellation Program Human Systems Integration Requirements, HSIR. And I feel the HSIR in particular is an excellent product, and we've distributed it to people in the military, and they've said this is great. We need something like this. One thing that surprises me in DoD, and it's going to be a topic of conversation, I'm sure, at this symposium, is that the DoD doesn't work to equivalent requirements. They work through other mechanisms. But to me, requirements in the NASA process gives us a foundation on which to build the other 6 capabilities. Without a firm set of requirements, we'd have a hard time going to programs and projects and arguing, well, we need a requirements integration team, we need a verification team. But we have a good set of requirements integrated into the programs and projects for HSI concerns, and I think that puts us in a good place, but it also separates our culture quite a bit from the current practices in the DoD. As I said, I feel that requirements is the foundation for the circle of 6 capabilities. It's important for programs and projects to embrace our requirements and make them their own. And in doing so, programs and projects have very specific ways that they want requirements to be written. And we're finding as time goes on with our relatively small sample of new human spaceflight programs that the process is more and more stringent over time, which to me is a good thing because it forces us to be objective, look at validity of our requirements, look at measurability and verifiability of our requirements. And our requirements would not be in the HSIR if they couldn't meet these measures right now. Also, it requires us to be thinking about rationale for each requirement and a verification statement. It's a very good thing. But one of the messages here in that horizontal integration process is that that's largely driven by programs. So we can take a program driven set of constraints and use that to perform horizontal integration across HSI domains. That's not always the case. Programs don't always provide us the structure to do that in some of the other the 6 capabilities, but we'll talk about that. Within space life sciences, I feel we've developed good social integration tools, which is a term that I find that DoD practitioners using. And just one cultural difference here between us and the DoD, it's what I call the small town syndrome. JSC is small enough to where we can get the right people in space life sciences together in a room and talk face to face when we have differences of opinions among the different domains. JSC is small enough to where we can sit down with the program managers and talk about our differences and reach resolution. The DoD is so extended and so big, they're dealing with something akin to 700 to 800 acquisition projects at any one time, and the different domain capabilities might be spread in different states. So the Habitability group is in a different state than the group that has responsibility for human factors. So they're not always as able to meet face to face and talk through differences. And we need to learn more about that and the tools that they develop to counter that, because we do have an extended network ultimately, because there are human factors and other HSI domain practitioners in other states that we always need to bring to the table. This is just an example of some of the topics in our standards, primarily to let the DoD personnel know. So let me move on to the next of the 6 capabilities, requirements integration. Requirements integration I'm defining as any process with the goal of ensuring that requirements are understood and flow to all levels of development. In other words, we don't just take our requirements, good as we feel they are, as well integrated and well vetted into the program as they are, and throw them across the fence. It's always important for our subject matter experts to be able to engage with the program, because not everything that comes up in a program is thought about during the requirements development process. So there are always issues that come up that we need to be interfacing with the program. We need to help engineers understand our requirements. We need to help designers and people responsible for the acquisition contracts understand our requirements. And again, like I said, there's always unknowns that surface. The goal here is to reduce the risk through the development process of our requirements not being met. We don't want to end up at verification, at formal verification at the end of the development cycle, and there be any surprises that our requirements might not be met. So the requirements integration teams are always there to help people understand the requirements and reduce the risk of the requirements not being met. This requirements integration process is typically met by teams of people who have subject matter expertise in a particular domain. And just as an example, one of course I'm familiar with, the human factors team, we've had successful requirements integration teams since I came into this branch in 1994, where on Space Station Program, human factors was treated as a system equal to other systems in that program's systems engineering and integration process. And that's where we want to be. We want human systems integration. We want human considerations to be an equal consideration with other systems in the systems engineering process and management. Again, our social integration tools within space life sciences forums such as the Ops Tag and the Risk Forum are very useful to address commonalities and differences among the different domains when we're talking about requirements integration processes. This next chart just shows, especially for the DoD personnel, a few of the titles that we have. The important thing, I think, that will surprise some of the DoD personnel is that these are program-recognized titles. So at the Constellation Program level, we have, for example, a Human Systems Integration Group Lead with that title, program-recognized title. In the CEV project, we have both a Human Systems Integration Lead from Space Life Sciences Directorate and a human engineering subsystem manager, as well as subsystem managers for environments, radiation, space medicine, and food systems that are recognized by the program. And that is an excellent place to be. We want the program to recognize these, and the program funds the existence of these teams as well. That will be different than the DoD culture, I suspect. Design. Design is one of the 6 capabilities, and perhaps it's because the chief of this branch and the deputy of this branch both have architectural backgrounds, but we saw years ago that as well as our requirements might be written, as well as we might have teams working with people in the programs to understand the requirements, sometimes requirements aren't enough, and you have to roll up your sleeves and get involved in the design process. And we developed a capability to do that along the way. We brought in people with architectural backgrounds and industrial design backgrounds and created the Habitability Design Center within the branch. A perfect example of this, what I'm talking about here, comes to mind from Space Station Program in the late 80s. The challenge was to, how do we get something as simple as the location coding labels in the space station, the ones above the racks, to look the same in all the modules? When the modules are coming from different vendors, different countries, how do we get those labels to look the same? And there were people in the space station program at the time that said we have to do that by writing Word requirements. And I'm reminded of the legend of the 6 blind men describing an elephant. One goes up to the tail and says, well, I think an elephant's like a rope. One goes up to a leg and says, well, I think an elephant is like a tree trunk. One goes up to an ear and says, well, I think an elephant's like a sail. We couldn't throw enough words at this simple problem to ensure commonality. What we wanted to do was simply give them a picture, say, make this label look like this. And yet there were people in the program who said, we can't do that. We're issuing a design solution. You've got to write requirements. You've got to write Word requirements. Finally, the division chief there said, especially when he was handed a price tag from the vendor saying they wanted $200,000 to write this requirements book, that give me a picture. And that led to our managing a set of the decal catalog for the International Space Station, where when we want commonality, we simply give them a design solution and say, it should be like this. To extrapolate that to larger systems, that is the opportunity that the Habitability Design Center is looking for, particularly in habitability, where we found that it's something of an emerging field, and exactly what constitutes habitability was still a work in progress. So we have found the HDC to be particularly effective in programs that spend time in the conceptual design phase, and particularly with NASA teams before they issue a contract. It becomes harder for engagement of HDC at this time once a contract is let. But a few examples of capabilities of the HDC. Sometimes we do graphic prototyping, making recommendations on what a design solution might look like. These are some example user interfaces. Here we're working with a team looking at possible ways that lunar habitat might be established. And here we're looking at stowage labels and stowage systems. Physical prototyping. This group has the capability to build models and full-scale mock-ups. This is a model of a module. This is a model of the interior size of CEV when we were first looking at, well, how big should this be? And then particular systems. But the Habitability Design Center is not just a model shop. The important capability that makes it something beyond that is user evaluation, because the data that comes out of this facility isn't a mock-up, it's the evaluation by the users. It's taking one design versus another design and saying, in the operational period, this one is going to be more effective because we have that user feedback. And we're doing this early enough in the design cycle where we can inform the developers and help make design decisions when it's cost effective to do so. So what does this have to do with horizontal integration? these evaluations in particular can be broad enough to be cross-disciplinary among HSI or space life sciences or health and medical technical authority domains to be inclusive. And it's in the evaluation phase that I feel there's opportunity for cross-discipline integration. The remaining three, verification, I'll touch on fairly quickly here. Verification is not just the formal process where at the end of a project we formally accept that our requirements are being met. To me, verification is a continuum that reduces risk through the entire development cycle to ensure that once we get to that point, we're not going to be surprised. Verification is also some rigor that early on communicates to the designer what kind of test or analysis or demonstration is going to be needed to confirm that a particular requirement is met. So there's some rigidity, if you will, to the verification process and discipline that needs to be incorporated into it. Requirements integration teams are often the ones monitoring this process through the entire development cycle. And again, just like requirements development, verification processes are often very strictly defined by programs. They're program managed processes. So the horizontal integration across domains can be dealt with simply by compliance with the program requirements for verification. Sometimes the challenge for HSI is ensuring that everything is objective and measurable and verifiable all the way through, and that we're not making subjective demands at all. Operations, that's the ultimate proving ground for the other four, the first four that I talked about. In order to, our requirements, or HSI in general, often doesn't manifest itself until the operational period. The development cycle is the development typically of the hardware and the software systems. As I said up front, we're always looking at human system performance, human plus system performance. And the two typically don't come together until they're deployed in the field. So how can we do predictive measurements in the development phase to help ensure that when operations come, there won't be surprises? We have a lot of forward work to do in this area to develop those predictive models. And the DoD says this is one of their biggest concerns too. How do we take objective information back to the program managers during development that says, well, design A is a whole lot better than design B and it's going to save you money? So I think this will be a topic of conversation at Human Systems Integration Symposiums for years to come. But for us, participation in operations means that we have to have an active program to monitor operations, monitor the performance of our requirements during the operations, and we do, although there's forward work that we need to do to ensure that we're collecting more objective data in this area. Again, our social integration tools within space life sciences are useful, very useful to get together and talk about operational concerns, the ops tag and the risk forum. Research. Research, some may think, is not part of the life cycle, and it's not typically. But as I said about the 6 capabilities model early on, it is what I feel, the 6 capabilities are what I feel are needed to have a very viable, in our case, human factors domain program or habitability domain program, because research gives us the opportunity to establish the long view. Research gives us the opportunity to say, well, what didn't work? What didn't we know that we can go back and perform research on in order to fill this gap? And we don't have to wait for the end of a program to do that. We're always learning. Even during the development cycle, we're always learning of areas that we need to get smarter on. We need to develop techniques in order to gather more objective data to help satisfy a program concern. So research, to me, has to be an equal and capable part of a viable domain program. Fortunately, in NASA, in space life sciences, or in HSI concerns, we have the Human Research Program, which is an extremely effective tool, and it allows us to do directed research, directed at solving program problems. One of the metrics for the human research program is what benefit is it having on the current NASA human spaceflight programs and projects. That is a tremendous asset to us, and we can definitely cite examples where HRP has helped solve current Constellation Program problems and concerns. So finally, coming back to the message, again, this is the message for this conference, for this conversation, and for further conversations, side conversations at this symposium, is that what we're proposing, or what we postulate might be of some benefit to a D model, is to break that horizontal integration process down into components. These 6 capabilities are the ones that I cite. It's the ones that I've used as a model within our branch for years as capabilities that that we need to have. There might be others. But the important thing is to break that horizontal integration process down into subcomponents. I think each of these horizontal lines is worth a paper in itself. As I said all along, the requirements integration, I meant to say requirements development. Sorry, error here. Requirements development and verification project processes or capabilities are usually very well defined by a program, so they give us a method to tie all of our concerns together. They give us a format. They give us a format for requirements, for verification. They give us a structure to that drive horizontal integration among our different domains. But the other 4, I feel the burden is on an HSI mindset to pull together and maintain those capabilities. So it's up to HSI organizations, and throughout this presentation I'm using the term HSI, a reminder, even though there's no formal HSI program within NASA, because it's going to communicate to the particular audience this pitch was designed for. But HSI in particular must develop that capability to participate in design and in research. I feel those capabilities always have to be there to have a fully effective domain and cross-domain program. And I feel that the way we work provides lessons learned for some of the DoD practitioners. And finally, although nothing I've said here is formally codified in NASA right now, I feel that this reflects in actuality the way we work, and that gives us a pretty viable HSI equivalent program that horizontally integrates our human considerations. And that's my presentation. Are there any questions here in the room? Okay, I'd like to pass the microphone on then to Doug. Doug is going to be presenting a presentation that's also going to Human Systems Integration Symposium 2009 in a couple of weeks.
Let me go ahead and introduce Doug real quick. Thanks, David. That was really good. Appreciate that. Just a brief bit of information about Doug. Doug works in our Habitability and Human Factors branch as well here at JSC, although he came to us by way of Langley a few years back. Doug's an aerospace human factors engineer, and he also has a Master of Science degree in mechanical engineering, and he holds a professional engineering license in the state of Virginia. And Doug's had a lot of varied background in his work, but he's definitely done a lot of work in the human-centered design area. And his paper today, he'll talk to you more about this human factors interface with systems engineering for NASA human spaceflight.
First off, do I know how to use the clip? Thank you very much, Debbie, and very nice to meet all of you here and those audience outside. I guess earlier you have heard about the tools that we have developed in terms of human systems integration. What I would like to do now is to sort of give you an overview on what we are doing in our branch to promote the human systems integration idea as part of the NASA's systems engineering process. And I'm going to be talking about, just explain where we come from, okay, this model called human as a systems, and also talk about our past success, some of our current endeavors, and what we plan for the future. So who we are? Okay, we are the Habitability and Human Factors branch, and we are a part of the Space Life Science Directorate over here, or SA. And our main product is Human Factors Engineering, and we've been supporting the NASA space program since 1987. So some of the work that we do includes human factors, habitat designs, and developing requirements and usability analysis, and space human factors research. Human as a system design model. I think our success in the past couple of decades has a lot to do with our promotion of the human as a system design philosophy. What is it? We think that the human are ultimately the main user of the system, so the systems are actually should be designed to be used by the human, and also humans should be considered as part of the system, or as the system within the system. And as a result, the human factors disciplines we believe should play a very prominent role in the overall system design process. And you see a picture over here, the Spider-Man that you see at the bottom over there, which is actually not our product, but I just couldn't help it. I saw this picture online. That sort of gives you a very dramatic example on what a human systems integration is. We have really done a lot in the past 20 years or so, and this is just a list of some of the more major things that we have done. We have certainly done a lot more than this, but I would like to go over this just because of their implications and how important they are. You have heard a little bit on NASA Standard 3000 earlier in David's talk, and we're very glad to have our original developer here, Barry Tillman. He's also in our audience, and among others too. The NASA Standard 3000 was released slightly over 20 years ago. I won't go into the age thing, okay, over here, but you sort of get an idea. It is a major human design guide for space equipment, and I'm very proud to let you know that in addition to the space community, this document has been used widely, I can say worldwide, in the space in the human factors community in general. It also has many applications for terrestrial environment, just as long as you recognize that there are some particular requirements that are tailored towards a micro-G environment. Okay, and there's a subset of this document. It's called the NASA Standard 3000T, which is a specific document we used for the International Space Station as a contractually binding human factor systems integration design requirements. And for those who are interested, you can actually go to the website as indicated here to learn more about this document. I think the document is actually online. The NASA Standard 3000 is not the only thing that we do for the International Space Station program. We have also created a flight crew integration group, and the main job is to analyze human factors related issues for the International Space Station. And a very important component of FCI is the OPHABS team. And their main task is to collect and analyze space mission data, and also conducts the crew debriefs. And the crew debriefs that they conduct are not only limited to the ISS, and they even go into some space analog environments to collect the necessary data. They also conduct focused evaluations to identify human factors and habitability improvements. And I'm going to talk about this a little bit later, but the data that they have collected are actually going to be used for the update of the NASA Standard 3000, which is the 3001. And not just that, the lessons that we have learned from the ISS are also incorporated and benefit some of the subsequent space programs. One of them, a more prominent one, is the Orion Space Vehicle, the CEV. We also play a major role in the development of the NASA Systems Engineering Handbook. The handbook was first published in 1995. It basically is a systems engineering guidebook that is tailored to the NASA systems engineering environment. And then in 2007, it came out with the latest revision. In the revision, in addition to making some updates, it also incorporates a section on human factors, which is actually developed by our branch. And in this section, it helps to promote human factors engineering as a recommended practice, and it also stresses the important roles that the human play in human space flight. So more particularly, the human is a critical component of the mission and the system. And it also provides human factors engineering analysis techniques and methods as a summary. And for those who are interested, the book is available for download in a PDF form in the following website. HFB, our branch, also manages the Space Human Factors Engineering Project. The Space Human Factors Engineering Project is an element of the NASA's Human Research Program, and the goal is to develop human factors, standards, and models to ensure that space systems design are compatible with the crew members, both in the sense of physical and cognitive. And back in 2005, we have conducted research in technology, a gap analysis. In this analysis, we try to address some key questions that will help us design the future CEV vehicle. And then to do that, we conducted a series of white paper reviews, and then we augmented these white papers with some subject matter expertise knowledge, and also some of our historical Apollo and Skylab reports. And also the space, what we learned from the space station, we have also taken a great benefit out of that. And now the SHFE is sponsoring many research activities at NASA to try to address the gaps that's been identified. One of our lab facilities in our branch is the Lighting and Environmental Test Facility. Back a few years ago, we see with the ever-increasing complexity in space operations, especially in shuttle and space station environment, we see the need to develop a new kind of lighting system. Okay, but there, as you know, in space there are some very stringent requirements. For example, durability and low power. Okay. So at the end, we have decided to use the then new LED, light eminent diode technology, for general illumination. Nowadays, you see LED technologies being used quite often for example, your handheld flashlights, and they are very low in power, very high brightness. But we have been doing that for quite a long time, and we ended up developing the ring-mounted LED lighting system. around the shuttle cameras. And then we didn't stop there. We actually also developed the illumination system for the space shuttles. In June of 1998, we flew the first set of illumination systems on the shuttle. And then in a subsequent flight in 1999, we actually increased the number of LEDs to 180. And then last year, we actually evaluated our first prototype LED lighting systems on the ISS. You can see that on the picture over there. With the lighting system, it dramatically increases the viewability on many of the surfaces on the space shuttle. Yeah, we have certainly done a lot in the past decade or so, 2 decades, but we didn't stop. We have continued our efforts, okay? And I'm going to talk about a little bit more about those. First is the NASA Standard 3001, and it's an update of the NASA Standard 3000. It's currently in work. We anticipate that it will be published sometime this year, and it defines spaceflight system standards for crew health and performance. And this version will have 2 volumes. And volume 1 will be on crew health, and volume 2 will be on habitability and environmental health. And that's just like the older version. It also has another spin-off design handbook. Okay, and we'll be using the design handbook to guide any future spaceflight design and develop requirements. And with our success in the International Space Station, we have really drawn much attention to other NASA space programs, and one of them being the Constellation Program. So now we are actively involved in the NASA space program. The Constellation Program, Human Systems Integration Group, we are actually leading that, and it's a program level authority. Besides many important responsibility, it also is the developer of the Human Systems Integration Requirements, the HSIR, which has become a very important document in the Constellation Program. And I believe David also mentioned about that earlier. And then in addition to that, we also developed the crew interface labeling standards, which has also been widely used. So nowadays, the HSIC play a very important role in many of the constellation projects, such as the CEV, the EVA project, Altair, which is the lunar vehicle project, ground ops, and also the Ares rocket. So go down to one more level. In addition to the involvement in the program level, the HSI activities, we also have a very strong involvement in the Orion project in itself. Our main responsibility is to do resource planning and allocation, develop requirements oversight, and validation studies and strategic supports. Okay, I am actually involved in this project myself. My main job is to conduct human-related modeling and simulation validations, which is a very critical area and an art in itself. And in addition to all those, we also play a very important role as the conduit between our parent organization, the Space Life Science Organization, and the Orion's Health and Medical Technical Authority. And then we are also very involved in the risk identification and mitigation, and also have many independent studies to address unresolved human factors and health issues. Another very important facility we have is the Anthropometry and Biomechanic Facility, or ABF. And recently it has been a major player in the Constellation Program, so EVA project, the extravehicular activity, project. Their main goal is to develop a new spacesuit. So in this process, they have identified some key anthropometric factors to help improve EVA development. Our goal is to help facilitate human factors engineers and others to develop the new spacesuit for the constellation. Our lighting environment test facility, in addition to creating LED lights, when we look into the future, we're thinking of using some newer technology that's available now, especially in the area of emergency egress lighting system. And we have identified a very new technology called the organic LED. These are very high brightness and very extremely low in power organic polymer, and they will greatly reduce the maintenance costs and without compromising the safety of space operations. Let's just spend a slide on this future of human-centered of our NASA endeavor. I've talked a lot about using the human as a system philosophy, but really our ultimate goal is to develop, introduce this philosophy we call the human-centered design, because we believe that human, since we are as the user of the system, any system should be designed around the human, and therefore we recommend a holistic iterative human-centered system design method, and we think this method should go through a spiraling and iterative process, and to explore as much concepts as possible at the beginning, especially at the beginning of the process. And we should consider the entire life cycle, and we also think that in addition to most of the disciplines, we also need to include others that we may not be able to think about in the future. What we plan to do in the near future is to update the next version of the NASA standard systems engineering handbook with some of the HDCP relevant languages. So this is a summary. I think we have done a lot in the past 2 decades. And we will still continue our endeavor and try to promote our HASS model. And in the future, we would like to introduce the HCDP, the human-centered design philosophy, also in this systems process. And because we really believe that it will greatly enhance our quality in all the in future space developments. I think that's all I have, and I will be glad to accept any questions. This is a list of the bibliographies I have conducted during my research on this paper. Okay, I guess that's all we have. And thank you very much.
Thanks, Doug. That was really great. We appreciate your taking the time today to give us a preview of your paper and your presentation. And that concludes the presentations that we have for today. So I would invite anybody in the audience, if you have any questions, you can either, give them to us now, or you can always go on to our website. Remember, we do have a SharePoint site that we showed earlier. And we'd love to have you visit and see what's on there. It's, in work. So let us know if you have any suggestions. And if you have any proposed topics or presenters, or say, hey, have you thought about talking about this or putting this slant on it? We'd honestly love to hear it. So feel free to give me a call. And for those remotely, again, my name is Debbie Burdich, and I don't have my email up there, but I will. But you can always go on to that Knowledge Broadcast website and just let us know what you're thinking. And thanks again for coming here today, or for listening in today and supporting us, and we hope you'll join us the next time. Thank you.